Hello and welcome to section 7.1, which is on ratios and proportions. A ratio is a comparison of two quantities by division. And if you remember from 7th and 8th grade when we talked about ratios, they can be written in three different ways. They can be written as a fraction, so like A over B. It can be written with a colon, A colon B, or with the word 2 in it, A 2B. So three different ways of writing ratios. One example. A bonsai tree is 18 inches wide and 2 feet tall. What is the ratio of the width of the bonsai tree to its height? To be able to do this, first thing you have to do is convert them so that they are both the same measurement. You can't have inches to feet. So 18 to 2 feet, it would be 24 inches. So 18 to 24. And then you should always reduce it if possible. So it would be a ratio of 3 to 4 if you reduce that. An extended ratio compares three or more numbers. And I have an example of that here. The lengths of the sides of a triangle are 4 to 7 to 9. That's a ratio. It's more than two sides that they're comparing. The perimeter is 60 centimeters. What are the lengths of the sides? You can set that up into a little equation to solve this. So 4 times whatever x is plus 7x plus your 9x is going to give you 60. So if you add up your x's, you get 20x equals 60. Go ahead and do your last step there, divide it. So therefore your x is 3. And then you need to actually plug it back in to see what you got. So 4 times 3 would be 12. Centimeters, I suppose we better label it. 7 times 3 would be 21 centimeters, and 9 times 3 would be 27 centimeters. And so then if you reduce those, it would be 4 to 7 to 9 for the ratio. A proportion is an equation that states that two ratios are equal. So in other words, just like 1/3 equals 2/6. That would be a proportion. Those two things, when both are reduced, equal the same exact thing. That's a proportion. Proportional means equal. Extremes would be the first and the last numbers of a proportion. So of this proportion that I just wrote right here, the extremes would be the 1 and the 6. The means are the middle two numbers. So the means of the proportion that I just wrote would be the 3 and the 2. Cross products property. In a proportion, the product of the extremes equals the product of the means. Crisscross applesauce is what I taught you in 7th grade for solving proportions. So for my example here, what is the solution of the proportion? So if I started with 15 over x plus 1 equals 3 over x. I can do the whole crisscross thing. 15 times x is 15x. And 3 times x plus 1, you're going to have to do a little bit of extra work here because you're going to have to use the distributive property. 3 times x is 3x. 3 times 1 is 3. So it equals 3x plus 3. Then I need to go ahead and solve that. So minus 3. Actually, I better be subtracting the 3x since I have x's on the other side. So I have 12x equals 3. Dividing by 12 to get the x by itself. My x equals 1/4. So there's my answer to that proportion. So if I plugged the 1/4 back in for both of those, it should equal out. I have some properties of proportions that we need to look at. Properties of proportions, and you have to make sure that A, B, C, and D, that none of them equal 0, because if they do, that's gonna mess up the whole deal. The whole thing would be equal to 0. So if I have A over B equals C over D, that is equivalent to B over A equals D over C. All I did was flip both. The reciprocals of both still equal. As long as I flip both, I'm fine. A over B equals C over D is equivalent to A over C equals B over D. So what did I do there? I switched the means around. I put the C where the B was and the B where the C was. They're still going to equal each other. The third one, A over B equals C over D, is equivalent to A plus B over B equals C plus D over D. What am I doing there? I'm adding the denominator, the bottom number, to all of the numerators, which is the top number. They're still going to equal each other because I'm doing the same thing to both sides. So I'm going to use those three proportion rules or properties to solve some problems here. So for parts A, B, and C, or A and B below, use the proportion x over 6 equals y over 7. What ratio completes the equivalent proportion? And then you have to justify your answer. So you have to say which one of the three rules you're using to be able to solve this. So if I have 6 over x, if you look at the original proportion here, it said x over 6. So what did they do? They flipped it. So then guess what? I have to flip the second part. So it's going to equal, and I don't want to try to write inside those boxes, it'll get too messy. So it will equal 7 over y. Which rule did I use? I used the reciprocal one. So rule 1, could you say that? Rule 1, which was the reciprocals, still equal. This one, I have what over what equals y plus 7 over 7. Well, which one was it where I added the bottom to the top? That was the third rule, right? So if I do that to this first part of the proportion as well, I would have x plus 6 over 6, and then it equals your y plus 7 over 7. Which rule did I use there to do that? I used the property of proportions, the rule number 3. This one, where you add the denominator to the numerator. So continue along those same lines using those rules. I can get a little more detailed here. It says explain why 6 over x minus 6 equals 7 over y minus 7. Explain why is that equivalent to x over 6 equals y over 7. So I'm probably going to have to do a couple steps here to be able to solve this. So first step, I would probably, so I'm taking this, right, and I'm trying to turn it into this. So the first step, I'm going to flip them around so that my x is on the top. And when I do that, when I flip both of them, I am using the reciprocal, right? So that's rule 1 from up here. This rule right here, the reciprocal rule. Okay, so now I have it in that format, so the x is actually on top. Now, how can I get it so that it just looks like this? Well, if you look here, what would help you get rid of that minus 6 and the minus 7? It looks to me like if I added the bottom to it, I would cancel it out. So if I have x minus 6 and then I add the bottom to it, which is plus 6, then I have the over 6, I have the y minus 7 plus 7 over 7. Minus 6 plus 6 cancels, minus 7 plus 7 cancels. So what do I have left? I have x over 6 equals y over 7. So what did I use to do that one? To do this step right here, I used rule 3, which was this one, adding the denominator to the numerator to be able to go through and solve that. So this whole section is dealing with ratios and proportions and then using those 3 rules to solve some problems. So bring that knowledge with you and we will talk about it more the next time I see you. Have a good night.